Hi dear students, let us continue the next point or next problem in the sets. In a previous video, people have already studied that what is the definition of a set and what are the types of the set and what are the representation of the set. What is a set? Set is a collection of well-defined objects and representation of the set. There are two types of the representation. One is the set builder form or a tabular form. Another one is the roster form. And apart from that, types of the set. What are the types of the set? People have studied, that is what is a singleton set, what is a empty set or a wide set, and what is the finite set, infinite set. Now, based on that one, finite and infinite set, people have taken some example. Let's take the two more examples. Example: state which of the following sets are finite and infinite. They are given some set. We need to recognize that whether it is a finite set or an infinite set. First one is x such that x is a natural number and x square is less than 36 is that. X is a natural number and x square is less than 36. Whether it is a finite set or infinite set. I just named this set as a, let A is equal. Which form of the set it is? It is a set builder form is that. Now we need to get the, or else directly you can say that whether it is a finite or infinite. If you are not getting this point, means let's write in terms of the roster form. X is all the natural number and x square is less than 36. Suppose if you got the x square is equal to 36, what will you get? What people used to write? X is equal to plus or minus 6. But here x square value is less than 36. X square value is less than 36. Whatever the x value just take, after taking the square, that value must be less than 36. And now, and x must be the natural number. Can I take the x value is 5? If I take an x value is 5 square, 25. 25 is less than 36. Yes. So, and apart from that, x is equal to 1. 1 square value is 1. 1 is less than 36. So, possible value is 1. 0 is not possible to consider because x is a natural number. Natural number start with the 1. If I take an x value as 2, yes, this also 2. Next 3, 4, 5, yes. If I take an 6, x is equal to 6. What happens? 6 square is equal to 36. 36 is less than 36. It is equal actually. But here less than their value. It is not true. Therefore, only these elements are present. That means whether it is a finite or infinite, it is a finite set. That's all. Which is no need to write this roster form of the set. Directly you can conclude it. If you got the point means you can directly write it. Here it is a finite set. That's all. Now next one. Second one is x such that x is a natural number and x is prime. X is a natural number and x is a prime. I just named this set as a b, let b is equal. So x is a natural number and x is a prime number. Already know that prime number set. What is a prime number? A number which is divisible by itself and the one is said to be a prime number. A prime number set is an infinite set and here x is a natural number. All the prime number we are going to write 2, 3, 5, 7, 11 like that. We are going to write whether it is a finite set or infinite set. Obviously, it is an infinite set. This type of question will arise for 1 mark. Next one, x such that x is a natural number and x is an even number. And x is even. X is a natural number and as well as x is even. So that it is a finite or a infinite. Directly you can say or write in a roster form. Here it is a set builder form is that. So whether x is natural number is that x is a even number. Even numbers, natural number, natural even numbers, finite set or infinite set. It is an infinite set. What are the elements are present in this set? 2, 4, 6, 8, 10, 12, 14 like that. It continues. It is an infinite set. Next one. X such that x is a natural number and x is greater than 100. X is a natural number and X is greater than 100. Whether this set is finite or infinite. I just thought this set as a B. Whether it is a finite set or infinite. X is a natural number, X is more than 100. More than 100 means 101, 102, 103, so on like that. So it is an infinite set. Infinite set. That's it. This type of question will arise for 1 mark. It's very important type of the question. Okay. Now the next one is type of the set is subsets. What is meant by subset? Okay. Suppose the set A is that a set A. Sets are always denoted by capital letters of an English alphabet. Suppose the set A is that. I need to say that this is the subset of some another set B. So here a set A is a subset of another set B. This is the set A is said to be a subset of set B. When it is if every element of the set A has present in the set B. Every element of the set A, whatever the elements are present in the set A, all those elements must be present in the set B. In such case, we can call it as A is a subset of B. Are you clear that? All the elements of A must be present in a set B. All the elements of set A must be present in a set B. Then the A set is said to be a subset of set B. It is denoted by A is subset of the set B. A is a subset of set B. Read as A is a subset of B. Here B is said to be a superset. B is said to be a superset and A is said to be a proper subset. A is said to be a proper subset. In this case, A is said to be a proper subset and B is said to be a superset. Now, I just take some example. What is the example means? Suppose set A is that. What is the set A is nothing but even number less than 10. 2, 4, 6, 8. I just consider the B set. What are the elements are present in the set B means 1, 2, 3, 4, 5, 6 on up to 10. A and B are the two sets are there. Now can I call it as A is a subset of B? What is the definition of a subset? All the elements of the set A must be present in a set B. All the elements of the set A must be present in a set B. Whether 2 is that? Yes. 4 is that? Yes. Natural numbers are the first 10 natural number. 4 is that? 6 is that? 8 is that? Obviously, we can say that A is the subset of B. Here, A is a proper subset of B. Here, proper subset B is said to be a superset. This is the definition of the subset. What is the definition of that? A set A is said to be a subset of B. If every element of A must be present in a set B. It is mathematically denoted by in this manner. A is a subset of B. Here A is said to be a proper subset and B is said to be a superset. This is one example, general example I just taken. Next one is, and apart from that, I just take the several sets of the rational number. Can I say that rational number is denoted by Q? Q is a subset of the real number. Rational numbers are subset of the real number. Real number means we have already known that real number line. All the real numbers minus infinity to positive infinity. Here it is minus infinity, positive infinity. All the numbers are said to be real numbers. Rational numbers, a number which is of the form p by 2. Next, apart from that, can I say that natural numbers are a subset of the integers? Natural numbers are the subset of the integers. Natural number is the subset of the integer. People agree? Integer means positive integer as well as the negative integer. 0, 1, 2, 3, 4, 5, so on up to infinity. -1, -2, -3, so on up to negative infinity. Next, integer. Integers are subset of the rational numbers. Integers are subset of the rational numbers. Can I say that? Natural number is a subset of integer. Integer is a subset of the rational number. Rational number is subset of the real number. Simple again. So integer is subset of the rational numbers. Are you clear? Integer here. Natural number is subset of integer. Integer is subset of rational number, and rational number is subset of the real number. Like that. Now, the next one is here. Mathematically, we can say that A is a subset of B. In generally, we need to talk. Suppose A is present in a set B. A is present in a set B. A is subset of B means obviously A is must be present in a set B. A belongs to the set A. Already this is symbol if people are familiar. A belongs to the set A. Then we can say that A belongs to the set B. Whenever A is a subset of B. For example, one more example is take. A is equal to 1. Here we can write the same example is that suppose 2 belong to the set A is that. I am just telling that A is a subset of B. Obviously, you can say that 2 is must be present in the set B, and A is present in the set A. A belong to the set A, which implies A is must be present in the set B because A is a subset of B set. So this type of mathematical symbol of A we can express. Now the next point is intervals as a subset of real numbers. Intervals as a subset of real numbers, or just we can say that intervals. Intervals subset of real numbers. Real number denoted by capital alpha. Previously we just taken the intervals while discussing the trigonometry domain and the range of the trigonometry functions, closed interval, open interval, whole real number set, like that we have just taken. Now about the interval, we will get the clear picture here. Suppose here let A and B are the any two real number. I just take the A and B are the any two real number. Generally, I am just talking. A and B are the any two real number. Apart from that, our condition is that A is must be less than B. As compared to A and B, B is a larger. As compared to A and B, B is a larger one. Next thing is A and B are the any two real number. A is less than B. Then we can say that closed interval A comma B. Closed interval A comma B will be like say that, or else we can say that open interval A comma B and semi-closed open interval A comma B and semi-open closed interval A comma B. These are the four manners are there. These are the four way we can write the interval. What are those? This is the closed interval. This is said to be a open interval. This is the semi-closed open interval. Semi-closed open interval, and this is said to be a semi-open closed intervals. These are the names. Okay. Here I just make the table. Very important part. You just mention it. Write down in the notes. Anyway. So closed interval. What is the definition of the closed interval? I just write in terms of generally. Generally means a set builder form. I am just going to write. How the set builder form is nothing but x such that x is a lies in between A to B, whether is equal or less than A is less than or equal to x is less than or equal to B. This is said to be a closed interval. Closed interval is nothing but end points are included. That is general form I am just writing. Interval is nothing but a subset of the real number. Interval is subset of the real number A and B. Suppose the x value is that in interval A comma B is nothing but it is a subset of a real number. Obviously, it is also a set. Okay, set is that this interval. In this set, what are the elements are going to consider x value? How to choose the x value means x value we have to choose A is less than or equal to x is less than or equal to b. For example, it is a real number line is that minus infinity to plus infinity. Now, would you like to come to know that, for example, closed interval 1 comma 3. Closed interval 1 comma 3 value I need to get. Okay. So here 0 is that, 1 is that, 2, 3 and 4 so on. And here minus 1, minus 2 so on. Okay. In between, here in this interval 0.1 is there, 0.001 is there, 0.002 is there, here 1000, lakh, like that, crore, 1, like that. All the values are there, 2.1, 2.2, 2.01, 2.001, like that. Small, all the values are set to be a real numbers. Okay, anyway, I need to get to know that what are the values are present, what are the real numbers are present in this interval, closed interval 1 comma 3. 1 comma 3, it is a set is that, interval is a obviously set, subset of the real number. Already know the definition of the subset. What is the subset? Suppose it is a set A, set R is the another set, A is a subset of real number. A is a subset of real number. Definition: all the elements of the set A must be present in a set R. Yes, 1 comma 3, 1 to 3, 1 to 3. Whatever the real numbers are there, 1 to 3. Whatever the real numbers are there, all those real numbers are belong to this interval. Including the 1 and including the 3, in between 1 and 3, whatever the real numbers are there, all the real numbers are presented here. That means how many numbers are there? Here, infinite number of real numbers are there, because intervals always contains a infinite number of elements in it. Interval is a set. In this set, finite set or infinite set, it is always an infinite set, because interval is a subset of real number. Real number is nothing but infinite set. Out of that, if you return interval, here also there are infinite number of real numbers are there. Or else, can people count the numbers in between 1 to 3? All the real number 1 to 3, which is not possible. So that all the real number in between 1 and 3, including the 1 and including the 3, that is said to be a closed interval. That is, in general, you can write A is less than or equal to x is less than or equal to b. Here, x value, this we can split it. How to split this one? Means x is greater than or equal to a and x is less than or equal to b. This is we can write in this manner. Here, which value is larger as compared to a and x? Whether x is larger or a is larger? X is larger. On which side? This is open, that value is a larger. You can remember. Okay. So here, those who have wear the cap like that. Here it is open towards the x. This is the larger one. Here it is open towards the b. This is the larger one. Just for a hint to remember. Okay. Topi aksar larger. Okay. Anyway, here it is open towards the x. So x is larger as compared to a. Here it is open towards the b. So b is larger as compared to x. This value we can split, rewrite in this manner. Okay. Now I am just going to write 1 comma 3 is that 1 is less than or equal to x is less than or equal to 3. We can rewrite x is greater than or equal to 1 and x is less than or equal to 3, including the 1 and including 3. X value 1 will the h more than 1. More than 1 under right hand side, more than 1. X is less than or equal to 3, equal to 3 and less than, equal to 3 and less than. In between 1 and 3, all the real number present in this interval, that is nothing but it is an infinite set. So interval is a subset of the real number. What are the elements are present in this manner? We have to choose the elements of the interval. Okay, I hope you know clear. If you need, you just write the example. Okay. Now we can write this is the value. Now I just write the diagram. Real number line is this. Real number line is this is the positive infinity, negative infinity. closed interval a comma b is required. Closed interval a comma b. Here is the value a is there, here is the value b is there. I am just expressing on the real number line right now. Okay. Values for x we need to choose. Infinite number of values are there, including the a and including the b. A and b are included. In between a and b, whatever the real numbers are there are the real number. What I am just darken the line. Whatever darken line is there, all the values are present in the interval, closed interval a comma b. So remaining these values are not there and remaining these values are not. Closed interval a comma b is nothing but a is less than b. B is larger as compared to a. In between a and b, including the a and including the b are the real number. This is said to be a open interval. Similar, sorry, this is said to be a closed interval. Next, open interval. How to write the open interval? X such that a is less than x is less than b. A is less than x is less than b. For example, open interval 1 comma 4 is there. Open interval 1 comma 4 is nothing but on the real number line minus infinity to plus infinity. Here it is my 1, here it is the 4. 1 comma 4 is nothing but strictly inequality is there. A is here we can write 1 is less than x is less than 4. We can write x is greater than 1 and x is less than 4. X is greater than 1, more than 1. 1 is included or not included? 1 is not included. X is less than 4. X is less than 4. 4 is included or not included? 4 is not included. Now, apart from that, whether 3.9 is included in this interval? Yes, 3.9 is included in this interval. 3.99 is included? Yes, obviously included. 3.99, yes, included. 3.9999, yes, included. 3.999999 included. But exactly, approximately we can write it as 4 only, but not exactly 4. There is a small difference is that how much to become this value as 4, how much difference is that? 0.00001. 0.00001. That much of value is difference is that to become this value as 4. This value is present in this interval, but exactly 4 is not present. Are you sure? Similarly, 1 is not present, but 1.1 is present. 1.01 is present. 1.00000000001 is present, but exactly 1 is not present. Approximately we can write it as 1 only, nothing to worry. But this value is present in this interval, but exactly 1 is not present. This is the exactly meaning of the open interval. Is that clear? Okay. So I hope you have got the point. Now here, how to represent this value in a real number line? Real number line, I just consider the positive infinity, negative infinity to positive infinity. A is less than b. Here is my a. Here is my b. All the values in between a and b. In between a and b, all the values. Here, I just say that open circle. That means exactly at the a and exactly at the b, there is no values are present. Exactly at a and exactly at b, values are not included. Is that clear? This is how the points are present in a open interval. What is the difference between the open and closed interval? In a closed interval, n points are included, and in between these two points, all the values. Open interval, except the n point, remaining all the values. In between a and b, all the values except the end point. That is the open interval. Next, semi-closed open interval. Semi-closed open interval is nothing but x such that here closed square bracket is that n point is included. Here open bracket is that n point is not included. A is less than or equal to x. B is less than b. Are you clear? Here a is included, but b is not included. For example, minus 1 comma 5. Minus 1 comma 5. Semi-closed open interval. Real number line. negative infinity to positive infinity. Here it is minus 1, 0, 1, 2, 3, 4 and the 5. Here minus 1 is included. Minus 1 is included. Up to where? Up to 5. 5 is included or not included? 5 is not included. In between the minus 1 and the 5, all the real numbers are present. Minus 1 is included, but 5 is not included. That is exactly the meaning. Now, in general, if I will write a real number like this, negative infinity, positive infinity. Here is my A and here is the B side. Semi-closed open interval. Semi-closed open interval. A is included. Okay. A is included, but B is not included. In between A and B are the real numbers. Okay. These are the values. Okay, this is the semi-closed open interval. Similarly, semi-open closed interval. Semi-open closed interval. That means x such that A is less than x is less than or equal to B. In this case, A is included? No, A is not included. Whether B is included? Yes, B is included. I am just going to write directly. It is the positive infinity and the negative infinity. Here is the A and here is the B. A is not included. A is not included, but B is included. B is included. In between A and B, all the values. In between A and B, all the values are said to be a semi-open closed interval. These are the four types of the interval: closed interval, open interval, semi-closed open interval, semi-open closed interval. And closed interval is nothing but endpoints are included. Open interval is nothing but endpoints are not included. That is the difference. If you have the square bracket, endpoint is included. If you have the open bracket, endpoint is not included. You just write down this table. If the space is not sufficient, you just write the diagram at the below. Okay. Next one is power set. Next one is a power set. So, as you people defined in the previous classes, there are several types of the set. One is a singleton set, which consists only single elements in it, and empty set, there is no elements in it, like that. Finite set, there is a countable number of elements present in it. Infinite set, there is uncountable number of elements are present in it. These are also to be depending upon the power. Don't depend it is the set which has the power is said to be a power set. It is not that proper definition. Anyway, what is the power set? Power set is a collection of all the subset. Collection of all the subset of a particular set. A collection of all the subset of a particular set A is called power set. Is called power set. What is the power set? Collection of all the subset of a set. So suppose one set A is there. Suppose the set A is there. For example, 1, 2 I just write. Only the small element I just taken. Less number of elements I just consider. There are 2 elements are present in the set A. I am just going to write the subset of this set. Already know the subset. A is said to be a subset of B. All the elements of A must be present in a set B. Okay. What are the subset we can write? A is a subset of itself. A is a subset of itself. It is one set. And singleton set 1 is a subset of this set. Singleton set 2 is a subset of this set. Observe that A is said to be a subset of A. All the elements of A must be present in here. This set is a subset of this one. Yes, 1 is present. This set is subset of this set. Yes, 2 is present. And as well as null set. And as well as null set is also a subset of the given set. So, what is the power set? Power set is the collection of all the subset of a given set. Power set is the collection of all the subset of the particular set A. What are the subset of A? A is this set. This subset is A. Singleton set 1, singleton set 2, and the null set. These are the 4 subset of this set. Collection of these 4 sets is said to be a power set. That is denoted by P of A. That is denoted by P of A. P of A is equal to A, singleton set 1, singleton set 2, and the null set. Always, while writing the subset of a particular set, a given set A and the null set are always subset of the particular set. You people would like to write the subset of this particular set, whatever, subset of A, subset of B, whatever the set, subset of the natural number, subset of the real number, subset of the whole numbers, or subset of the integer, whatever is this type. Writing subset, set is itself a subset and as well as null set. Null set is also subset of other set. Okay, very important point. After writing the set is itself a subset and the null set remaining elements. If you have the two elements, single set and two elements, like that you can write. Are you clear about the power set? What is the power set? Power set is a collection of all the subset of a particular set. As is denoted as the set, whatever the set you can write. Another example you can take. This is the example number 1. Second example. Suppose the set B is that contains an element 1, 2, 3. Or else I just take the contains an element A, B, C. Suppose the set B is contains an element A, B, C. In that case, what are the subsets? B is a subset of itself, and as well as null is subset of itself. Next, singleton set A, singleton set B, and singleton set C. Apart from that, only these are the subset. No, still the remaining values, two values A comma B and A comma C and B comma C. These are the all subset of the given particular set. These are all the subset denoted by P of B. Power set of B. Power set of B is nothing but subset of all the set of the B. Subset of all the collection of subset of the set B. How many? 1, 2, 3, 4, 5, 6, 7, 8. Here, to write the subset or to find the number of elements of the power set. Already know the number of elements in a set A. For example, number of elements in a set A is m. Now I need to get that number of elements which are present in a power set. Number of elements which are present in a power set. To find this one, it is sufficient to use the formula 2 power m. It is sufficient to use the formula 2 power m. 2 power m. What is the m? M is the number of elements which are present in a given set. Come to the previous two examples. I need to find the number of elements which are present in a power set. How many elements are present in a power set? 1, 2, 3, 4. Formula is 2 power. M is nothing but number of elements in a set A is 2. 2 square is 4. Come to this one. 2 power. P of B is n of P of B. M is nothing but n of B. What is the n of B? Number of elements in a set B is 3. 2 cube is how much? 8. Got it? 1, 2, 3, 4, 5, 6, 7, 8. 8 elements got it. So this is the formula to find the number of elements which are present in a power set is 2 power m. Where m is the number of elements present in a given particular set. Very important formula or very important definition. Based on this definition, we will get the 1 marks question sometimes. So very important type of the question. Now the next thing is inversion. Universal set. What is the universal set? Universal set definition is there are some sets. There are some sets under consideration. Under consideration, the subset of there are some set under consideration are the subset of the largest set. Subset of the largest set is called that largest set. Subset of the largest set. This largest set is denoted by or called as a universal set. That largest set is said to be a universal set. What is the universal set definition? There are some set under consideration are the subset. Whatever the set we are just consider, those sets are subset of the largest set. That largest set is said to be a universal set. For example, suppose A is equal to 1, 2, 3, 4 is that, and B is equal to first 10 natural number. First 10 natural number, and set B is equal to, I just consider 2, 3, 5, 7, and set C is equal to 1, 3, 5, 7, 9, and set D is equal to 2, 4, 6, 8, 10. Here there are some sets under consideration. Here set already B is there. I'll just call this as a B. There are some sets under consideration. These are there are some sets under consideration are the subset of the some largest set. Are the subset of the largest set. Out of these 5 sets, which one is the largest set? Largest set is nothing but depending upon their cardinality. How many elements are present in it? How many elements are present? 4. Here also 4. Here 5 elements. Here also 5 elements. And here 10 elements are there. Out of these 5 sets, which one is the largest set? U is the largest set. There are some sets under consideration are the subset of the largest set. These are all the subset of the largest set. Check it. Whether A is a subset of U. Yes, all the elements of A present in a set U. Whether B is a subset of U. Yes, all the elements of B present in a set U. Whether C is a subset of U. Yes, all the elements of C present in U. All the elements of B present in U. So these are all the subset of U. These are all the subset of the largest set. Then this largest set is said to be that universal set. Is said to be a universal set. Universal set always denoted by the capital letter U. Universal sets are always denoted by the capital letters U. People clear about the universal set. What is the universal set? There are some sets under consideration are the subset of the largest set. Then that largest set is said to be a universal set. Whatever the largest set you have just consider, that set is said to be a universal set. This is a particular example. Here we can write A is a subset of U, B is a subset of U, C is a subset of U, and D is a subset of U. Very important point, universal set. Okay. Now, sometimes they used to ask us questions that write the subset of the set. Write the subset of the set. Write the subsets of the following set. Write the subset of the following sets. In that question, already people have written subset. Suppose the set A is equal to -1 and the plus 1. Write the subset of the set -1 and 1. Write all the subset of this set. What are the subset? -1, +1, null set, and set is itself a set. This is said to be a subset. These are all the subset of a set A. And next, similarly, B is equal to 1 omega square. Write the subset of the set B. What are the subset of the set B? Singleton set 1, singleton set omega, singleton set omega square. And we can write 1 comma omega square, or omega square, the whole set B and the null set. You can cross verify. Already know that how to find the subset of a given set. Formula is the number of subset of a given set 2 power m, where m is the elements which are present in the set. 2 power 2, 4 elements. 2 cube, because number of subset of a set B is 2 power m, where m is the number of elements in a set B. How many elements are there in a set B? 3 elements are. 2 cube is 8. I got the 8 set. Check it. 1, 2, 3, 4, 5, 6, 7, 8. Yes, this is how we have to write. Very important for the 2-mark question. They used to ask it. Okay. Now I just stop here. The remaining problems based on the types of the set and intervals, subset definition problems will continue in the next video. Okay. Thank you.